Hi guys, so today I want to talk to you about the cosine rule. What I've got in front of me here is actually just a screenshot of your log tables, just to, I suppose, highlight some of the information that we have done so far. So you can see the first thing on the log tables is actually they're reminding you that if it's a big A, it's an angle, and if it's a small a, it's a side, or vice versa. They have written here the sine rule. So they have angle over or side over angle, side over angle, side over angle here. They also have this one, area is equal to half AB sine C. So if you haven't learned about area of a triangle yet, that's coming up in one of the videos shortly. We should know all about this already. Okay, but just so you know that it's written there, and we can only use those in right angle triangles. So them and Pythagoras is right angle triangles. But today the information that we're looking at is this cosine rule here. So remember, we use the sine rule when we have pairs and we might have one thing missing. But the cosine rule we're going to use in a different situation. So again, nothing to do with right angle triangles. These two are just to do with all triangles. When you look the cosine rule up in the log tables, this is what you're going to have written here. A squared equals b squared plus c squared minus 2bc cos A. Now there's a lot of information in this, but two bits that I would say are super important is to make sure that your A and your cos A, the angles, so that the side and then the angle here are a pair. Because once you have those, the B and the C, it doesn't matter which you pick to be B and which you pick to be C. But the A is super important. You use the cosine rule in two cases. You use it if you are given a triangle where you are given three sides and you're asked to find an angle. Or in this case here where you're given two sides and an included angle. And so often people say that this angle here that you're looking for, this angle is very cosy because it's stuck in beside two sides. And so some people will remember, oh, well, if it's a cosy angle, I will use the cosine rule. But, you know, for me, I always just try and think of it, if I've got three sides and I'm looking for an angle, I use it. And if I have two sides and an included angle, or a cosy angle as they say. Leaving certificate higher level, just so to make you aware, there is no ambiguous case with the cosine rule, and the reason for that is because if we're thinking back to our CAST, so the cosine rule is positive obviously in the first quadrant, and it's negative in the second quadrant. The only one that is positive is sine, which means it would need to be greater than 180 degrees to be in either of these quadrants, which obviously it wouldn't be if it's a triangle because it has to be an acute or obtuse. Okay, so just to remind ourselves of that. So we're going to use the cosine rule if we see a normal triangle where we're given three sides and we have to find an included angle, or if we're given two sides and an angle and we're looking for anything else. So we could be looking for this, we could be looking for a side, we could be looking for an angle, whatever the case may be. And likewise, in this case, we're obviously going to be looking for angles because we have all our sides. So let's take a question. Let's try it out and see how we get going. Okay, so find x, the distance from A to B. Give your answer to correct three significant figures. So again, you know, this question doesn't say use the cosine rule. We're asked to find x. We have to make the connection. I'm dealing with a normal triangle, so I can use the sine rule or the cosine rule with normal triangles. But have I got pairs? So, you know, you could look at it and say, well, that'd be one of my unknown pairs, but I don't have a matching pair, okay? Or I don't have 6 in this angle here, which means I can't use the sine rule. So I am going to use the cosine rule. Another reason why I'd use the cosine rule is because I have two sides and an included angle. So a nice cozy situation, as you might say. All right, so let's step one, write down our formula. Okay, so I said to you earlier before about these A's matching up is super important, okay? So I'm going to match up these two with the pair that I need, or you know, a pair that I know, whatever the case is, but I'm going to, they are matching up. So the only thing that matches up, a side and an angle, is these two here. So x, remember the small a is my side, so I'm now going to call that x squared equals, and then over here I'm going to write cos, and instead of writing cos of a, it's now going to be cos of 40. So making sure that these are a pair is super important. Your B and your C does not matter, okay? So I'm going to call this one B and this one C. Okay, so it's going to be 6 squared plus 8 squared minus 2 times, I better zoom in for this, 8 times 6 cos 40. So you can see here, guys, it's 2bc cos a, which means all of this, I'll put it in a blue line here, all of this is multiplied together. Okay, so we can do all of this really on your calculator, but I suppose we'll try and do BIMDAS first, essentially. So try and work out certain things first. But if you do 6 squared plus 8 squared minus, and then in brackets you can do 2 by 8 by 6 by cos of 40, your answer will be given to you. You're going to get x squared equals 26.4597. So again, with all of these things, type this into your calculator now so that you're getting the same thing as me. And obviously we're not looking for x squared, we're looking for x, so I'm going to square root both sides. So the square and the square root cancel, and I'm left with x is equal to root 26.4597 is 5.1439. The question says to 3 significant figures, so I'm going to x is equal to, so 3 significant figures means 3 digits, so 5.14 is the correct answer there. So take some time, have a look at what I've done there. Okay, so example 2 says calculate the measure of angle A. So I'm looking here and I don't have, well, that could be one pair, a pair I don't know, but I don't have anything that will work with the 5, or I don't have anything that would work with the 8. So the sine rule is completely out. So I'm thinking, oh, well, I have 3 sides. So if I know 3 sides and I'm asked to find an angle, it is the cosine rule. So let's write down our formula. Okay, so, you know, we use the A's really to find our pair and what we're looking for. So this is, I suppose, important. So we have our side, which is going to be 7 squared equals, and we're going to have nothing here, cos of A. So cos of that angle, which we don't know, so we're going to call it cos of A. All right, so again, the B's and C's doesn't matter. Once we have everything else right, this will work out fine. So it's going to be 8 squared plus 5 squared minus, I'll zoom in here, 2bc is 2 times 8 times 5. Okay, so you know obviously yourself what's going to happen here is we want to find A, so we want A on one side, everything else on the other. So there's a good bit of working out that we can do here. So I'm getting 49 equals, so 8 squared is obviously 16. Sorry, it's not terrible maths there. 64 plus 25 plus 8 fives is 40 times 2. So it'll actually be a minus, won't it? So it'll be minus 40 cos A. Okay, so going to try and, so that's going to give me 89, is it? Does that give me 89? I think so. So I've got 49 equals 89 minus 40 cos A, minus 89 on both sides. So I'm getting minus 40 equals minus 40 cos A. Okay, and I've just spotted a mistake. So this should actually be 80 cos A. So 80 cos A and 80 cos A here as well. Okay, so now I see the way I have minuses on both sides. I'm actually just going to multiply everything by -1, or you could swap sides essentially if that's what you're doing. So now I'm going to flip it around so it looks a little bit nicer. So I have 80 cos A equals 40. Cos A equals, so we're going to break it down. So it's multiplied by 80. So I'm going to divide by 80 on that side, divide by 80 on that side. So cos A equals 40 over 80. And then obviously we're not looking for, so we can say cos A equals 1/2. But we're not looking for cos of A, we're looking for A. So how do I get rid of cos? I do cos to the -1 on both sides. And I get A is equal to cos to the -1 of 1/2. You type that into your calculator and you're going to get 60 degrees. And that was what we were looking for there. Just to talk to you another way about the way the cosine rule can be written. So it can be written like this, which is cos of A equals b squared plus b squared plus c squared minus a squared all of 2bc. Which is, it's pretty much the same. All they've done is they've rearranged it, but just make sure that if you are going with this, that your big A and your small a are a matching pair. Okay, so I'm going to give you a learning check now to do on that. Okay, so the learning check is using the cosine rule on these two questions. You can see here I have two sides and an included angle, so a cosy angle. You're going to use the cosine rule here. And then here it's the other situation where I use a cosine rule, which is when I have three sides. So I'm going to just do a quiz now next where you can input your answers and we'll see how you get on.